Okay, example 4-4 is about a trapezoidal channel with a longitudinal slope of S0 equal to 0.005, and it's made of fine finished concrete. So at the side wall, it's concrete lined. So this length is covered with concrete. And then we have the rock cuts and two. So this wall, so the wall here, and the bed, the channel bed is rock cut. So they have different roughness. So here we have N is equal to 0.013. And then for these two walls, we are going to have N equal to the value for rock cuts. So we need to find out what is the value for rock cuts. So 0.035. So you can find it from the table. In the chapter 4. So if you go to the chapter 4 of the textbook, then there is a table which you can calculate the or find the value of Mannings for different material. So when you go for the rock cuts, then you can find the value is 0.035. So that's from table 4-3. So I write it here from table 4-3. Okay, so the channel carries a discharge of 15 cubic meter per second, and the sidewall slope of the channel is 1 vertical to 1 horizontal. So here M is equal to 1. And the bottom width is 6 meters. So P2 is 6 meters. So we need to calculate the normal depth and Froude number. So the question suggests to use the Felkel formula to calculate the equivalent Manning coefficient, because we have different type of roughness. So we need to find the average. Assume that the channel wall made of rock cuts, and calculate the initial depths and continue the calculation for 2 iterations. So the Felkel formula gives us a value for equivalent Manning roughness, which depends on the wetted parameter. So we don't have the wetted parameter because we don't have the normal depth. So we can do try and error. So here in this example, we have area, which is B0 times Yn. So that's the rectangular part. And then we have the triangular part, which is M divided by 2 Yn to the power of 2. So it's going to be B0 plus M over 2 Yn times Yn. And the wetted parameter is the bottom width, depth, plus the diagonal, Yn square root of 1 plus M squared. So now in this case, we need to set up the Excel file. So we'll go to Excel. And then here we start the equivalent Manning constant as 0.035. We use the rock cut value. The bottom width is 6 meters. Sidewall slope is 1. Longitudinal slope is 0.01. And then here, discharge is 15. And then in the right-hand side, I calculate the area. So this is the area, B plus M divided by 2 times Yn. And then everything divided by Yn. And then here we have divide by equivalent Manning constant. Then area divided by wetted parameter to the power of 2/3 multiplied by a slope to the power of 1/2. Okay, so we want to make sure that the right-hand side and left-hand side are the same. We start with 1. So you'll see that here we have 11. And then I need to increase. So I put 1.2, getting close to 15. 1.22 is more than 15, maybe 1.21. Okay, that's very close to 15. Then in the next step, I'm going to calculate the equivalent Manning constant based on the given depth. So I need to calculate the weighted parameter of the sidewall, which is square root of 1 plus m squared. So 1 plus m is 2, and then the square root of that times depth. So now I have P, I can calculate NE from Felkel equation. So here from Felkel equation, I have the weighted parameter plus the bottom width multiplied by the Manning's constant of the rock cut, and then plus the bottom width multiplied by the value of concrete, the Manning constant of the concrete, the sidewall multiplied by the Manning value of concrete, divided by the total weighted parameter. So now I find the equivalent Manning constant. I'm going to, basically what I do is I drag this down, and then I drag everything down from here. And then I do another try and error. So I start from 1. So I got 14.64, maybe a little bit more, 1.1. So it's 17, 1.02, 1.015. Yeah, close to 15. And then calculate the weighted parameter again. Then I'll go one more step. So basically I drag this down. So you want to make sure that you calculate the value of the Manning constant for the rock cuts. So this is the only change we need to do. You'll see that. And then we have the weighted parameter, and then I drag this down. So if I put 1.02, maybe more, 1.03, very close, 1.035, 1.033. Yep. So we get a better estimation of normal depths. We can do another trial, see that it's very fast. So what you need to do is you can just adjust the value of NE, drag this down. So I need to reduce the value here, 1.032. Yes, 1.031. Yeah. So you'll see that we start with 1.2 and then quickly converges to 1.03 meter. Yeah. So we can keep continuing this, but then you will see that the change would be very, very small. And that's what you can do in consulting companies. So here I have 14.985. Maybe if I increase this a little bit. Yeah, so you'll see that we got our solution converged. And then we need to calculate the fruit number. So I develop the value of fruit number. What I do is I just use the latest value of yn. So sidewall slope and bottom width is constant. I'm just using the latest value or the most updated value. And then I get the fruit number of 0.728. So that's it.